everyone. Today we will discuss about another problem of linked list. So which is like how to find intersection of two linked list. So what we have to find is, or what is the problem statement. So we have one linked list like this and another linked list like this. So we will be provided with both of their head node, and we have to find out like where they are intersecting this node. So that means the 44's next node, if you see, that is also 55, and 202's next node, that is also 55. So both are coming like this, and they are growing, and they are ending like this. So we have to find out this node 55 where actually both the linked list are intersecting. So we will first see like what is our first approach number one to solve this problem. So here is the first linked list and here is the second linked list, and both of their head is provided to me. So here I have marked their node addresses, like the first node address is 1101, and then second node is 4409, and then third node address is 1223, and the insertion point, this node's address is 3423. Okay, so this is our desired one actually. So now first approach wise, what we can do is any one of the linked list. So any one of the linked list we can first traverse full. Then while traversing, that time we can store these addresses in a hash set. So for example, I am traversing this linked list. Okay. Then you can see here this addresses I have stored in a hash set here: 1101, 4409, 1223, 3421, 3423, 2334, 5678. Okay, so now next what we have to do, then we have to traverse through this second linked list, and we have to check one by one address if it is present in this hash set or not. So first I am checking 1119, this address is not present here. Then I am checking for 4444, that is also not present. Then I am checking for this one 3423, and this one is present here in this hash set. That means this 3423, this node is my answer. So this is one solution, but for this solution, one thing you can see here is if you talk about space complexity, here actually we are taking on extra space, means for storing this addresses in a hash set, that is taking on space, means the length of this linked list. So maybe you can think if we are storing address of this linked list, that time as the length is less, maybe we can store in some less space, but then we have to traverse more, right? So that way if the linked list length is very high, that time actually more space is required. So this is, we will not say a best approach, we will see the next approach. Okay, in approach number 2, we will take two pointers. One we will point to the head of this first linked list, another we will start from this second linked list head. And then we will move these two pointers together, and we will check the present node where actually the pointer is present, if the address is matching or not. Okay, so first actually I started it from here and then here also. So it is moving from 11 to 22 and 101 to 202, and we are checking if both the addresses are same or not. So in this case you can clearly see here this 4409 and 4444, these two addresses are not matching. So we have to go forward. Here also the address of these two are not matching. Then third iteration, there also this address and this address is not matching. Fourth iteration, there also this address and this address is not matching. Then this will end here only because next to null, and it will keep on going for next two iteration, and then it will also end. But we don't get our desired result because we don't find any match when we are moving them together. So why it is not matching, that we have to check now. Now we have to see like when we start this pointer from head of the both, then why they not matched here. So why they are not matching here, because this length and this length before this insertion point is not same, right? So if you start from here and if you start from here with same speed, so you can't reach here in the same time, right? So because their effective length is different, so here we can see 4 nodes are present before this insertion point, and here 2 nodes are present. So if we start from here, means where actually before insertion point 2 nodes are present, same as this linked list, then both can reach same time in this insertion point. So that way we can get the result. So for that purpose, what we have to do is we have to, for the bigger linked list, so for the bigger linked list, here bigger means from insertion point the previous length where actually is bigger, so that we are considering as the bigger linked list. So for the bigger linked list, we have to move this pointer few nodes forward. In this case, 2 node we skipped, and from this third node we started our pointer, and then if we start at the same time and if we move one by one rotation and check their addresses, then we can see we are getting the desired result after 2 iteration. Now how we can calculate like how many nodes we have to move the pointer forward? So that how we can do is, so suppose this length is a, here it is 4, and this length is b, that means 2 nodes, and this length is c, so means here actually it is 3. So one thing is clear from here, like a plus c is actually the length of first linked list, and b plus c is actually length of second linked list. That means a minus b is actually length of the first linked list minus length of the second linked list. So if we have to write the program, then what we have to do is, first we have to find the length of the first linked list by iterating once, and then we have to find the length of the second linked list in the same way by iterating once, and then we have to get the difference between these two. So that will be a mod value actually, means here in this example this linked list is longer and this is shorter. Maybe for other example, maybe this one is bigger and this one is smaller. So you have to take the mod value. Then for the like which linked list has bigger length, from there we have to advance the pointer that a minus b number of nodes, and then we have to start from there. And then if we start this both the pointer from this point and this point, then they will match here where actually the address we can find, and that will be our desired result field. Okay, so now one more case also can arise. If you are getting two linked list where actually they are never intersecting, so maybe this is a use case also they can give, right? So actually if they are not at all intersecting, so that time what you have to do, so that we will see next. So now if these two linked lists are not intersecting each other, means this is the first linked list I got as my test case, and this one the second one, and they are never intersecting, then that time what we have to do is, while actually we were traversing in the like previous discussion, what I actually told is, so if while actually we are traversing the linked list to get the length of this linked list, that time just keep the last address with you. Okay, for both the linked list. So for linked list 1 also, when actually you are traversing to get the length, so that time you keep the last node address, and for this list also you keep the last node address. If both are not equal, that means they never intersected. So in the previous case, the previous example which we were working with, that time this node was not present, so it was linked like this, right? So if it was linked like this, so for the second linked list also the last address should be 5678, and for this linked list also the last address is 5678. That means they are somewhere intersecting. But if their last node address is difference, that means they never intersected. So that way also you can do this check. And how to get this last address, you don't have to iterate again. So while actually you are for the length check, so while actually you are traversing, that time you keep this. Okay, when the last iteration you just keep this in a variable. Okay, so like hope you like this video. So how to get the insertion point of a two linked list. Okay, thanks for watching this.